And I want to look at running hypothesis tests and computing confidence intervals for data. In order to do this, I read in this table that is bears data. My variables are the ID, the sex, the age, the head length, head width, neck girth, chest girth, and weight of these bears. We can, of course, find out basic information by using commands like the mean of our bears, and we'll say we're going to look at the head length. So we can see that our mean is 13.43, but maybe we want to run a test where our null hypothesis says the mean is equal to 15, and the alternative hypothesis says the mean is less than 15. In this case, we're going to use the command t.test. The first thing I need to put in is the variable that I'm considering. I'm considering the head length. The second is I'm going to do alternative equal to, and I have three options that I can put here. I can put in 2.cited. This would be if I had a not equal to test. I can put in the word less for a less than test, or greater for a greater than test. However, my alternative says the mean is less than 15, so I'm going to use the command less. And then we tell it what we think the mean is, 15. By writing mu is equal to, in this case, 15. That tells us what our null and alternative hypothesis, the value in them. So if I run this, I get my t value, my test statistic. I get my degrees of freedom, and I get my p-value. And it even interprets this for us. The alternative hypothesis is the one we want to go with. We want to say the true mean is actually less than 15. We can also see a 95% confidence interval here. You'll notice it goes from negative infinity to 13.88. That's because I'm using a less than test. If I change this to two-sided, is it equal to 15 or not equal to 15? I can see the true 95% confidence interval of my data. I can also look at a two-sided test. So for instance, let's say I want to know does chest girth change with gender? In other words, do males or females have a larger chest girth? Or is it the same for each? Is males larger or females larger, or are they approximately the same? This is actually going to be a two-sided t-test. And in order to do that, we're going to do a t-test. We are looking at our bears data, and we're looking at the chest girth. However, I want to actually restrict myself to males versus females. So I'm also going to use these square brackets to say that this case I'm only considering the males, where sex is equal to M for male. And you'll notice I have this double equal to sign. That's very important. And then the M is in quotations. I want to compare this to the bears that have their chest girth, but this time I'm breaking it down to the females. So essentially this is saying that I'm comparing chest girth between males and females. And if I run this, so I have my p-value, which is 0.2871. My alternative hypothesis is that the means are not equal to 0. And this is a high enough value to say that my alternative hypothesis does not have enough information, we can in fact say that these are equal to 0. There is no difference between male and female chest girth.